or group 7, chemistry. Chemistry of group 7. So group 7, okay, I'll write it there. They are known as halogens. Group 7 elements. Known as halogens. Yeah, they form salts when they react with metals. So group 7 elements, okay? So physical properties, let's start from there. Physical properties. Number 1 is that the first 2, you have your periodic tables there in group 7. The first 2 are non-metals at room. The first 2 are, sorry, the first 2 are gases. They are all non-metals. First 2 are gases at room temperature. RTP means room temperature. The first 2 are gases at room temperature. Are we together?
Yes.
So that's fluorine. If you're looking at your periodic table, they're fluorine and chlorine. They are gases at room temperature. Then bromine is liquid at room temperature. Liquid at room temperature. Then iodine is a solid at room temperature. So the iodine is a solid at room temperature. Then the other thing that you need to know is that the color intensity. So color intensity increase as we go down the group. Color intensity increases as we go down the group. So we have to mention that fluorine is pale yellow. It's a faint yellow. Chlorine is greenish yellow. Then bromine is a brown liquid. Are we together? Then iodine is a black solid. Black solid. When it's solid, it's black. But as a gas, it's a paper vapor, but we'll talk about that now. Okay, so you see the color intensity is increasing from yellow all the way to black, huh?
Mm.
Are we together? Okay. So we're talking of color intensity. Now density. Remember, density is mass over volume. Huh? So density increase was the mass increase. If you check there, what's the mass of fluorine from your periodic table there? In that 9, just check.
It's 9.
Yes. Is it 9?
19.
It's
19.
19, sorry, yes. And the mass of chlorine, 35.5, huh? So can you see that it's increasing as we go to that? So because mass increases, density increases. Density increase as we go down the group. Then the last one is to do with melting points and boiling points. Melting points and boiling points increase as we go down the group. Increase as we go down the group. Maybe this one actually needs explanation. Why this happens. Okay. Now, if we check, okay, let's start with fluorine. I'll explain from the configurations. Fluorine, the electron configuration of fluorine is 2, 7. Then chlorine is 2, 8, 7. Then it continues like that. All right, together then. It will be 2, 8, 8, 7, something like that. Then it continues. So now we want to explain why the melting and the boiling point increase. So as we go down the group, the number of shells, the valence, the number of electrons in the last cell is the same. But what increases? Look at this. What's increasing is the number of shells away from the what? Remember, the nucleus is positively charged, but we are increasing the number of shells away from the nucleus. Are we together? So if we increase that, it means the force of attraction between the positively nucleus and the valence electrons weakens. Are we together? It becomes weak as we go down this group. Okay. Now look at this. Now, also remember these nonmetals, they attract electrons. Are we together? They attract what? Okay. So we're saying it becomes weak. So if it becomes weak, anyway, let's explain the first point. So if it becomes weak, it means now if that force of attraction, because when you're trying to boil or when you're trying to heat, you're trying to break the forces of attraction between particles. So if that force of attraction becomes weak between the positively charged nucleus and the valency, it means there's less energy that you require to break the bonds as you go down the group. Okay, I'm saying in general. If that was that was group 1, but now it doesn't apply here, because what happens with this? Remember, these they tend to what? To attract electrons. Is that true? They tend to attract electrons. Okay. If they attract, remember they are trying to attract electrons. So if they are trying to attract electrons, you see this number 1. Okay, we'll talk about the chemistry. So if they're trying to attract electrons, with this now, remember I said the boiling point and the melting point of these nonmetals increase. So what it simply means is the reason why the boiling point, okay, I think I mixed things, sorry about that. Now with this one now, we explain from your covalent bonds. Let's explain it from the covalent bonds. So all these molecules, these group 7, they exist as diatomic. For example, you have chlorine, bromine. It's always diatomic like this. So as you go down the group, the number of electrons, you have more electrons as you go down the group. So if we have more electrons, because we have more electrons, it means now the force or the covalent bond between these molecules becomes strong. Are we together? The covalent bond becomes strong because the number of electrons is actually increasing as we are going to go. So the covalent, if the covalent bond becomes strong, it means you need the high energy to break. Are we together? Therefore, you need high energy, but you rarely get such a question. Okay, now, so you need the high energy to break that. No, that's physical properties. We've been dealing with physical properties. So in chemistry, when you're looking at this, we always deal with physical and chemical properties. So never, okay, what you need to remember, okay, all of you there, if I'm talking of physical, let's talk about that, physical, so that you know the difference. If I'm talking of physical properties, I'm mainly looking at number 1, density. I'm saying in general in chemistry. I'm talking of the color or appearance. I'm talking of the state of the elements at room temperature. I'm talking of the mass. I also talk of the melting point and boiling points. These form physical properties. That's what we're talking about. This is to do with physical properties. Now, if we are looking at chemical properties, that's why we are looking at the chemistry of how they react and all that. Are we together? So chemical properties. Who has just joined us now?
Tapio.
Tapio, where were you? Had you forgotten the chemistry lesson? We are looking at group 7. I'll send the first part of the video that you have missed because I'm recording this video. Mr. Tapio, welcome back. We are looking at group 7 elements. If you have periodic table there, that's what you are looking at. Now let's look at the properties of group 7. So number 1, they have a valency of 7. All group 1 elements have a valence. Who remembers what valence means? Valency, what does this mean? They have a valence.
It's the number of electrons in the outer shell.
Yes, it's the number of electrons in the outer shell. So they all have, that's why they're called group 7. They all have a valence of 7. Okay, are we together? They have a valency of 7. That's the first one. Second one is to do with chemical. They are all diatomic in nature. So they are all diatomic. Diatomic in nature. What it simply means is you always find bromine on its own. It's always like this in nature. Chlorine, fluorine, and what? Like this, huh? Okay, are we together? We're saying they are diatomic in nature. Huh? They exist. So it means they exist as molecules. Okay. Covalently bonded together. Diatomic in nature. As molecules covalently bonded together. As molecules covalently bonded. Happy, are you there?
Yes, sir.
Okay. So that's your chemistry. Okay, they always exist like this, huh? Before they react. Now, we said they've got a valence of 7. Now, the other thing now, which is more important, is on this chemistry of these groups now, is let's look at now the reactions. So if you're talking chemical properties, then you have to consider the reactions. Okay. So reactions of group 7. Reactions of group 7. Number 1, they react with group 1 metals group 2 metals and group 3 to form salts, to form halides salts. Your stable sodium chloride is a reaction between sodium and chlorine. So to form salts. Now, let's talk of so what they are more interested in your syllabus is the group 1 reactions. Huh? The group 1 reactions. So, lithium plus chlorine forms lithium chloride. Oh, okay, solid. This is a gas at room temperature. This is a solid. This lithium chloride is not balanced. You put 2 there. You put 2. So this is a white solid. Now, the chemistry of it is the reaction is very slow. Is very slow at room temperature. RTP means room temperature. So we need to add heat. Are we together? Add heat. Clear? In terms of the reaction. So this solid, it is soluble in water. All group 1 soluble in water. They dissolve in water. Okay. Now the sodium plus chlorine, it gives you your table soda. You know it, sodium chloride. Huh? By now you should know this, the chemistry. So this is a solid. These are just states if they were to ask for states. Okay, like that. So again, a white table salt. Okay. Sodium chloride. Okay. The reaction, because sodium is more reactive, you don't need to add the heater. Are we together? So reacts steadily with chlorine. Are we together there? To form that salt there. Clear? If you add heat, you see a yellow flame of sodium. Okay, but normally you don't need to add. Then potassium. So you're only required to know up to potassium. So this is a vigorous reaction to form potassium chloride. Solid. This is a gas, G for gas there. So this is a white soluble salt. The reaction is vigorous. Potassium produces, K is for potassium. Potassium produces a lilac flame. You observe a lilac flame, it's because of potassium. Are we together? More of a lilac purple flame. Are we together, Tapiwa?
Yes, sir.
Okay, well, sometimes they'll ask you for observations, so that's why I'm mentioning this observation. The rest, you actually need to. So now if I'm reacting, look at this. I want you to see something. If I want to react sodium and bromine, do you think this reacts? Remember, I said reactivity decrease as you go down the group. Huh? We're saying reactivity decrease. So remember, we said this, I didn't even mention this one there. It's a vigorous reaction. So we said with the chlorine there, we said the reaction is steadily. Huh? So this is a vigorous reaction with this. With chlorine, it's a steady reaction. What about this? So maybe write it down, you need to know this. So bromine cannot react with sodium. You can write that down. Let's write it down. Bromine cannot, remember this is a liquid, it cannot react with lithium, sodium, or potassium at room temperature. I'm simply using the letters K for
So
those.
please, can you say it again, sir?
Bromine cannot react with lithium, Li lithium, Na sodium, or potassium at room temperature. Are we together? What I said is, if you react with fluorine, the reaction is vigorous. No? Because chlorine is the most reactive in group 7. If you react with sodium with chlorine, we said it's a steady reaction. Then we're saying with this one, it cannot react. Are we together there? So we have to use bromine vapor. So it means we heat the bromine until it's a vapor. So for both these, use vapor. We use bromine vapor. So in that reaction, it will be like this: sodium, solid. S stands for solid. Hope you can see my writing there. It's not that nice. Let me try to write so I don't confuse you. If I am writing this test, it means sodium, solid at room temperature, plus bromine. Now I'm writing a G. So if you see this G, it means it's a vapor. Are we together there? We heat it until it's a vapor, then we react it with this. So now you form your sodium bromide. So again, this is a white soluble salts. Are we together there, Sarah?
Yes, sir.
Okay. Just remember that most of the reactions of this are vigorous, huh? Because this is very reactive. Are we together? Especially reactive with group 1 metals. Now, maybe I'm sure we're just looking at time there. Yes, I think we still have time to look at that. Now, let's look at the special reactions called displacement reactions. Displacement reactions. So displacement reactions are to do with the reactivity series. Huh? Remember we talked about the reactivity series of this reactivity series of group 7. We said fluorine, chlorine, bromine, iodine. So reactivity decrease as you decrease as you go down the group. They decrease. So now that affects what is known as displacement. I'll explain it just now. Displacement reaction is like this. If I take, for example, potassium fluoride. Are we together? I want you to listen very carefully. Potassium fluoride, like this. If I am to react with chlorine, no reaction can take place whatsoever because chlorine, look at this, chlorine is less reactive than what? Than fluorine. So it cannot replace or displace a fluoride ion. Are we together? So now let's say the reason is that chlorine is less reactive than fluorine. Therefore, it cannot displace a fluoride ion from its compounds. Are we together? It cannot displace a fluoride ion. Clear, Tapiode? Now look at this.
Yes, sir.
If I have potassium chloride, let's write this as an example, plus fluorine, can this reaction take place? Yes. Because fluorine is above what? Remember we said fluorine, if you check from my period table, chlorine, bromine, iodine. So chlorine is the most reactive. It can displace this chloride ion. And what is formed is potassium fluoride plus chlorine gas. That's your chemistry. So that's what we mean by displacement, because fluorine is more reactive than what? Than that. Huh? So it can displace that. If you want to balance two there. Now, if I have potassium bromide plus fluorine. Fluorine can displace all because it's the one on top. So again, a reaction will take place, chlorine, fluoride plus bromine, like that. Are we together there? If I have potassium, let's say potassium chloride plus bromine, can this reaction take place? From
No.
what? It cannot take place because bromine is below chlorine.
No chlorine.
So no reaction can take place. Okay, if you understand this, let's look at potassium bromide plus chlorine. Yes, this can take place because this is above. So potassium chloride plus bromine gas. Now we together?
Yes.
Potassium bromide plus iodine, no reaction because iodine is less reactive. That's what we mean by displacement reaction. Okay, are we together, Tapiwade?
Yes, sir.
Okay, so slowly, I think we'll end it there today. Some of you, but anyway, so I'll send a video for some of you that came in late. Then we continue looking at displacement relation as chemistry lesson, and we look at questions. Okay. Okay, so see you next lesson then. But I have recorded this one, so I'll send just now. Okay. Okay, cheers.
Thank you, sir.
You're welcome.